Sounds great. Thank you, Madison. You can give me a thumbs up when we're ready. Okay, you went off video. Okay, ready to go. All right, welcome everyone. Thank you so much for joining us. You know, fortunately for technology, we can continue our climate conversations, and we're really happy to have a great group today and a really good speaker. So I'm glad you could join us for this really timely topic. I just want to let you know a little bit about the climate conversations. There is a small group of individuals who forms a steering committee to help come up with these monthly plans and carry out these monthly climate conversations with the mission of aiding and improving climate communication skills for all. We want to improve climate change related data collection and sharing of that information. We hope to motivate and support community-based climate adaptation work and increase climate communication conversation in more sectors and broaden the impact. The individuals who are involved in the steering committee right now come from the organizations of Minnesota Sea Grant, Wisconsin Sea Grant, the Northern Institute for Applied Climate Science, 1854 Treaty Authority, and Minnesota's Lake Superior Coastal Program at the Minnesota Department of Natural Resources. And we also get assistance from the NOAA, National Oceanic and Atmospheric Administration Office for Coastal Management. So we are really grateful for all the contributions, and I'd like to welcome any of you to participate in planning and carrying out these conversations if you have time and interest to do that. I am going to put in the chat box a link to a new link that we have on the Minnesota Sea Grant page. Very big thanks to them for creating a page for the climate conversations. We will list upcoming events on there, and now while we're on Zoom, we can easily record the conversation. And so last month's presentation is up there, and you will find that John Swenson from UMD giving the part 1 presentation about the long view of Minnesota Point. It was a really good presentation, so I encourage you to check that out, and you can find the link in the chat box. I would also like to just take a minute to let you know about the next climate conversation, which is May 19th. We always have these, almost always, on the 3rd Tuesday of the month between 12 and 1 p.m. Next month, we're going to be talking about motorized vehicles and transportation infrastructure, sustainability and progress. And it is going to be a small panel featuring someone from the city of Duluth in transportation planning, Minnesota Power, from their, looks like probably someone from the electric vehicle programs and services, and then the sustainability coordinator for the Duluth Transit Authority. So next month, May 19th, join us. You're already on the mailing list, but I will also add to the chat box a link to sign up for climate conversations if you are not already on the mailing list for that. So now I am honored to introduce this month's speaker, Brandon Crumweedy. He currently serves as the Great Lakes Regional Geospatial Coordinator on contract to NOAA's Office for Coastal Management. His work is focused on using remote sensing and GIS data for analysis and application to address real-world issues and provide solutions. Before working at NOAA OCM, he worked in the National Weather Service at the National Operational Hydrologic Remote Sensing Center. He has served as a contractor with the World Bank, researching water resource issues in India, Pakistan, and Nepal. He has worked as a procurement officer, and he has also worked in the U.S. Army Space and Missile Defense Command, working on missile defense early warning, where his interest in remote sensing and GIS began. Brandon holds a Master of Science in Geography from the University of Montana, where he studied glaciers and water resources in Mongolia, as well as Montana, as if he hasn't been around the world enough already. Boy, he's got an amazing background. Brandon currently holds both a GISP and Certified Geospatial Intelligence Professional Remote Sensing and Imagery Analysis certification. And if you want to know more about those, you can definitely ask Brandon. Put it in the chat box because I can't explain it. But I will invite you again to submit your questions using the chat speaker or the chat feature. So with that, I'm going to hand it over to Brandon and welcome him and thank him so much for joining us today. Brandon.
All right, thank you. Yes, I had to come off and mute through the web browser, thanks to some of the limitations with Zoom right now in NOAA. Thanks again, Julie, for the very warm welcome. And yes, I'm definitely honored to be presenting today as the part 2 of, as it is in regards to coastal impacts. And today I'll be talking about Lake Superior's water levels historically, recently, and currently, but then also too the coastal impacts that we've seen with these recent high water levels. And so just building upon that, I was asked to also, highlight some of the data and resources that we use within NOAA's Office for Coastal Management, as well as those resources available to our coastal communities to help with understanding the issues around erosion and impacts to our coastal infrastructure. And then lastly, definitely want to leave some time at the end here for any questions, comments, or discussion really as well amongst the participants on this call. So just to kind of set the stage here, the one thing that we want to talk about in regards to water levels is that they do fluctuate over time within Lake Superior. And that fluctuation can be as much as almost 4 feet or just a little over a meter. And so looking at that period of record, these are just a few numbers that keep in the back of your mind when we talk about record highs and record lows. So the record high, as it still stands today, was October 1985 at 183.91 meters. And that record low was all the way back in April 1926 at 182.72 meters. And so this is just to highlight, how much variability there is associated with water levels. And I should also point out that these numbers that you're seeing are based on the monthly average. So that's taking into account all of the water level measurements from the various water level stations across Lake Superior, an average to give you these values for each of these 2 months. And when we look at water level change over time, some of the questions that we continue to receive are, well, how much control is associated with the compensation works or the locks structure at the St. Marais River? And just to put some context here, I've put 2 dates when those were completed back in 1921. And then also the new or more recent Lake Superior regulatory plan that was developed in 2012 and implemented in 2015. And so long story short here is there is no real control per se, man-made control in terms of the water levels. What we're seeing is a natural phenomenon. And if we look back at the period of record here, going back to 1918, we can see where these past high water events have occurred historically. So in 2019, we were at 183.75 meters in October, 183.73 in 1986, and 183.70 meters in 1951. And again, now these are looking at the annual average, so taking all 12 months of the water levels for the year. And what's really interesting is if you go back even further in time, we see that there's 2 additional time periods where we've had these high water levels. And interestingly enough, these are right around 30 to 35 years. And so one of the questions we often get asked as well is, well, wait, do we see a pattern? Is this conclusive evidence? And unfortunately at this time, while it looks like there might be a pattern, there's really no underlying understanding on why per se this is happening. We do have climate research scientists, and I definitely am not a climate research scientist, within NOAA that look at various impacts. Things, for example, like the North Atlantic Oscillation or the Arctic Oscillation, and the strengthening and weakening of those systems, and how those might be playing out in terms of both temperature and precipitation patterns that we see here in the Great Lakes region. And so it is interesting to see these reoccurring. I guess the one caveat or comment I often tell people is, let's see what happens, I guess, in 2049 in terms of water levels in that regard. But again, part of it is we just do not have that long of a period of record as well to look at, to draw any conclusive evidence moving forward. So when we look at the recent water levels, and what I'm referring to in terms of recent was last year, because we definitely saw a lot of impacts in the region, and we were very close to breaking some new records. In fact, we did for several of the months last summer, set new average water level for the months in the summertime. October 2019, we were very, very close to breaking that long-standing record from October 1985. We were actually only shy by 1.18 inches. And so, if we go back and look at the historical low water level in recent time, back in March 2007, is right around 182.79 meters. And, a lot of people want to know, well, how much water is entering the system or how much is leaving and things like that. And we can do a really simple back of the envelope calculation here. We can look at how much change there is between the long-term average, or again, in this case, March of 2007, compared to October of 2019. We take the area of Lake Superior, we run these numbers, and it is quite staggering when you look at the net gain. And so taking into account water entering in and water going out of the Lake Superior Basin, it's over 62 million Olympic-sized swimming pools. And those typically hold over 660,000 gallons. That's a lot of water that comes into play in our coastal areas. It's a lot of mass. It's a lot of liquid that can be moved around. And so this is not just unique to Lake Superior. All of the Great Lakes regions have been experiencing this increase in water. And here's a graphic from our National Centers for Environmental Information through NOAA, showing the departure from average as it relates to the time period from January to December 2019 last year. And as you can see, much of the Great Lakes Basin is showing anywhere from 4 to, even in some locations, upwards of 16 inches of additional water from the average amount of precipitation that we typically receive in a year. You'll also notice that a large portion of the upper Midwest, as well as the central part of the US, was also experiencing much more precipitation. And of course, this accounts for the flooding that we see here in the Great Lakes in our coastal areas, but also the flooding we saw along, for example, the Mississippi River, the Missouri River, and the Red River and others in the US here. And so overall, it's just setting the stage for, we have a lot more precipitation, a lot more water in the system, and how do we deal with this increased volume? Taking a look at current water levels, this is the report from last March. We actually set new records in Lake Michigan, Huron. They are treated as the one system, Lake St. Clair and Lake Erie. And interestingly enough, Superior was only shy by a little over 1.5 inches last month. Ontario was a little bit more, over 7 inches there. But again, this is just helping us to get a better understanding of what trends we might see moving forward. The one thing that I like to highlight here is the precipitation. When we look at March, Superior, the basin itself, was at 103% of average. We're basically up by 1.78 inches compared to our average of 1.73 inches for March. When you look at the last 12 months, however, we actually are, maybe this is the saving grace, a little less than 100% of average. And so you know, if we would have maybe reached that 100% or exceeded it, we would have been having a lot more issues as well in our coastal areas. The one thing I do want to point out is when you look at the net water supply for March, it is interesting because Superior is over 2 times its average March water supply. Typically in March we have 46,000 cubic feet per second, but in this case we're over 100 or 103,000 cubic feet per second in terms of the water supply coming into Lake Superior. A lot of people want to, you know what's going to happen in, say, the next 3 to 6 months or even longer in terms of the water levels. And luckily, it's looking like we are going to stay at or perhaps even a little bit below. It's still a little hard to say with certainty, especially in 3 months to 6 months from now, what that looks like. The one thing I say is, you know, follow the graphs here, and these again are being provided by the Army Corps of Engineers on the left here, showing their predictions for water levels in the Lake Superior Basin. And so the line that you really want to pay attention to is actually this red dotted line, and then again this red area, because that is where they're forecasting right now out for 3 months. The gray area is showing, you know, their 12-month forecast moving out as well. We can look at things like the 3-month outlook from NOAA in terms of precipitation probability. And the thing I'll point out here is the arrowhead of Minnesota right now is it's showing about equal chances in terms of precipitation. We get into Wisconsin and again the other parts of the Great Lakes Basin, they are showing above average precipitation potentially there. When we look at temperature, again, equal chances in Minnesota, in northern Wisconsin, but warmer for the eastern half of the Great Lakes Basin, looking again at these next 3 months. And so the precipitation now for the next few months will be a big factor to look at. Temperature is more relevant when it comes to snowfall or precipitation typing during the winter months and knowing whether or not it might fall as rain or snow. And that's what, again, helps to develop these types of graphs that you're seeing on the left here in terms of the water level forecasting and outlooks that's provided by the Army Corps of Engineers. So we have all this water in the system, and we compound that with wind, we end up seeing the storms that we've experienced recently here in the Twin Ports area, up the shore, both the North Shore of Minnesota and the South Shore of Wisconsin. And I think what really resonated was, you know, storms like those that occurred back in 2018. The graphic on the left is one I use quite a bit. That was produced by the National Weather Service in Duluth, you know, where we were dealing with 14 to 18 foot waves out in the lake, and again, dealing with coastal flooding. And it's really evident when you look at the NOAA Co-op's water level station in Duluth here. And, you know, within 30 hours, we saw a rise in water levels of 15 inches, and then they were elevated for over 24 hours. And that's what led to a lot of the erosion and impacts we saw during that particular storm event back in 2018. And so, you know, here's the photo from 2018. We've seen similar photos from the storms that impacted last October in 2019. And again, we can look at, you know, how it went all the way back to 1975, where we had flooding down Canal Park there in March associated with the blizzard event at that time. And again, you know, a lot of the focus was down in the Twin Ports area for that particular storm event, but we also saw this occurring upshore as well. And the reason I bring this to our attention is, you know, if you were only to look at the graphic the National Weather Service produced for that October 2018 storm event, it basically cuts off Grand Marais. And the point here is that we saw these impacts all the way up our shore. It wasn't just localized to the Twin Ports area. And so when you start to think about, you know, not only the impacts in Duluth, but up in Grand Marais and all the points in between, we really are seeing dramatic impacts to coastal infrastructure, increased littoral transport, erosion, and this is what's really been an interest of mine is, where are we seeing these impacts and how big of an impact are we seeing? We can look at the last, 3 years or so, and that's actually what this graph is showing is in 2019, you see the blue line representing water level at the Duluth Co-op's water level station there. Red line is from 2018 and 2017. There was a large storm event back in October 27th of 2017. And again, it was, kind of the first wave of these large storm events that have impacted the Twin Ports area here. The one thing I will show though too is, we've seen these storm events coming time and time again. Here is one back from September 12th, and I've actually got images in this presentation that show some of the impacts associated with that particular storm event. And again, the October 2018, you can see the prolonged high water levels associated with this one, and similarly back in with the September 2019 storm event. But what really set things ablaze in the world of high water levels and impacts was this particular event. October 21st, 2019, we exceeded well over 184 meters in terms of the water level being reported at that particular station. And it was very evident. We had, flooding prevalent down in the Canal Park area. We had lots of erosion occurring, even on the bay side. I've received photos from colleagues at the reserve, showing inundation way up by Oliver Bridge. It was a very large event. Luckily, it did not have the longevity as the October 10th, 2018 storm event, because that certainly would have led to potentially even more impacts in our coastal areas. The reason I also bring up 2019 is it is pretty remarkable when you look at the water levels being reported at the station in Duluth. The red line is actually showing the October 1985 monthly average at 183.91 meters. And what I want to point out here is, right around late May, which is highlighted here, and moving forward throughout the summer, and then again into the fall, was the simple fact that we had these elevated water levels. And again, some of these are associated with some storm events, but with these water levels elevated, and again, impacting coastal areas, it has a much further inland reach. And that's why we were seeing a lot of the erosion along Minnesota Point, up and down the North Shore, and again, over along the South Shore in Wisconsin. And then again, when you get a large storm event like what happened in October, and this is actually even showing too, large storm events that happened around Thanksgiving in November, it's pretty remarkable with this elevated water level. These are the reasons why we're seeing the amount of damages associated along our coastal areas. And so what does that all include? Obviously, the one that's easy to see is the amount of shoreline erosion that is occurring. We are seeing increased sediment transport. This is really evident when you look at things like satellite imagery, whether that be the coarse resolution of the MODIS or even high resolution data. We're definitely seeing the alterations to stream in river mouths where the streams are trying to carry sediment that might have eroded upstream in the watersheds, but because the water levels are elevated, it slows down that sediment from delivering into the lake, and you end up with these large river bars present at the mouths of these streams. We're seeing damage to the coastal infrastructure, water levels topping over seawalls and causing erosion to occur on the backside of those seawalls and weakening them. We've definitely seen the flooded marinas and docks. There's even the concern, especially if there's shore power associated with those docks. There have been reports across the Great Lakes of electrical shock drowning, where somebody walks into the water, the shore power is still producing electricity, and of course, since they're out in the water, they get electrocuted. And then again, that shock causes them to fall into the water and drown. This is also presenting some hazards to navigation. That can be either with the additional capacity of debris entering into the water, trees, other materials, docks, things like that, that have been washed away and sit really low into the water. Or it can also be the development of offshore sandbars. Again, new sediment entering into the system, and those aren't showing up on the charts. And so people have, hit those with their fishing boats or other small watercraft. We're definitely seeing impacts to coastal, terrestrial, and wetland habitats. One of them that comes to mind really quickly is at Illinois Beach State Park, where we've seen breaches of the foredune structures and directly eroding the wetlands now, because again, they had the water in there. That energy from the wave movement offshore and in the lake is transferring into those wetlands and is causing some devastation there as well. We have definitely seen the shrinking of beaches for recreational use. In fact, there are some beaches in the Chicago metro area that are completely closed because there is no beach there. And so that's definitely caused a dramatic need for recreational opportunities with the beaches. And again, it's going into the summer and now put COVID-19 on top of that, limiting those recreational opportunities that may exist in the highly built out metro regions of our Great Lakes region. We're also seeing the increased wave run up, as I showed with the water level station information, but that's not even factoring in the full run up that we see. And so we're seeing more and more of that water reaching further and further up on the terrain, and again, entraining sediment and washing and eroding structures. In case here's an example of this in the upper right. This is one of the pullouts along Scenic 61 that is continuing to erode over time. And then again, working with our coastal management programs, we definitely have been hearing about the damage and loss of private property, the photos that are in the news of houses falling into Lake Michigan along the sand bluffs there. It's really disheartening because, you hope to have that home that's along the shoreline only to see it wash away, 20, 30 years later. And so definitely has a direct impact there. So this being the climate conversation, I wanted to definitely bring into play, how does climate change connect to all this and the coastal impacts? And so part of the reason why I'm so enjoy studying the coastal zone is because they are very dynamic, and especially from the geomorphological standpoint. We have a lot of exogenic or surface processes that are occurring through the interaction with water, wind, wave, and ice. And that's probably the other thing that makes working in the Great Lakes so unique is we do have to deal with ice conditions as well. And so when we look at water in terms of increased precipitation, so obviously the increased water levels that we're seeing in the lakes, but that's also leading to increased saturation of our shoreland areas. And especially if we have, clay bluffs or sandy bluffs or sand dune structures, with those saturated lands, and then again being eaten away at the bottom with increased water levels, we have seen increased numbers of mass wasting events. And this is not just a phenomenon that's present in the Great Lakes. Actually, with El Nino and La Nina cycling along the West Coast in California, we see mass wasting events being triggered when you see differences in climatic patterns like that. Again, changing the regime in precipitation. When we look at wind in things like increased storm severity, that definitely increases the wave action that's present. Larger waves, 14 to 18 foot waves becoming very common almost in the Great Lakes region. And then of course, the unique things here include ice. When we see changes in temperature regimes, introducing more freeze-thaw cycling, we see increased physical weathering along our shorelines. And so that can be either, the bedrock that we see along the north shore of Minnesota, but that it can also be the clay bluffs in Wisconsin there. Ice can be both destructive, but it can also be a protecting force as well. And so when we do lose shore fast ice, and again, this last winter was really evident of that, it definitely increases our exposure of the shoreline to these winter storm events that do occur. And so again, it exacerbates the geomorphic processes that can interact with those shorelines through time. When we talk about these differences in climate and the physical setting, that also can cause some issues. And so we can look at erosion in regards to slope. And so, if we have something like a very flat beach, we end up with these spilling breaker type of wave platforms. If we have a much steeper beach, we can end up with what are called plunging breakers, and these are very erosive. And then again, with a very steep beach slope, you may get these surging breakers where they break and then again wash up the shore. They can potentially cause some deposition, but they also can lead to increased erosion. And so if we look at something like the bathymetry here, this is Big Bay in Cook County, areas that are in red are much steeper. And then again, areas that are in blue are much more of that flat or near flat beach condition. And so this is, when you start changing wind directions and having the wind coming out of the optimal direction, it can definitely change what type of waves you may be dealing with along the shoreline. And again, whether or not you're having erosion or deposition occurring, and at various rates based off of that offshore bathymetry slope. And this is just an example. Again, here's the photo from the September 12th, 2019 storm at Canal Park. And again, you can see that plunging wave just offshore. Whereas you can look at Pedagogue State Park, and again, this is from January, we have those vertical surfaces, and that wave, as it runs into those headlands, is forced to break upwards and splash out and up. And so again, two different settings, two different wave patterns. And again, the interesting one here with the January photos, you can see the interaction with the ice as that spray is also built up onto those vertical surfaces. It's really interesting to see pre and post storm photos along our shoreline and looking at the rates of change. This again is associated with the October 21st, 2019 storm event, Brighton Beach, where we've definitely seen a lot of erosion occurring. And so here is the same location, 1 week apart, almost to the minute. And it's amazing to see the amount of erosion here along the shore. The other thing that's really interesting here too is the amount of woody debris that is deposited along these shorelines. And so, one of the things that there has been some research done is on the utilization of large woody debris as shoreline protection. A lot of these studies have been conducted on the Pacific Northwest, up around Seattle and Victoria, British Columbia, and primarily not necessarily for wave attenuation, but more or less as a dampening force for that wave energy directly on the shoreline as it's crashing. Additionally, these large woody debris piles can serve as a sediment trap as well for that landward erosion, and again, preventing all this fine sediments to potentially travel across the cobble beach here and again into the lakeshore or into the lake. And so that is something that people are looking more and more into, especially from the natural-based infrastructure for coastal resiliency. We can look at places like McQuade Safe Harbor, and again, what's really interesting here, if you've been to McQuade, you know how elevated this sidewalk is compared to the water levels, but just to see the amount of debris tossed up here, the size of the debris. The other thing that's really interesting here is, here's a handrail that was being held on by 8 bolts, and again, just completely ripped off from that structure. Again, here we're highlighting the impacts to safe recreational opportunities. This is McQuade Safe Harbor again, October after the storm. And even after the storm, we had the high water levels here. And you can see that the docks, while not completely unusable, certainly if you're somebody that might be handicapped, having to cross through water like this does not make for a fun recreational opportunity at these particular structures. And then lastly, debris transport. It's really interesting when looking at McQuade Safe Harbor. You can see these structures that were put along the sidewalk to prevent people, from falling over, or again, just kind of being a guide there. But again, these were ripped up off of the concrete itself. And interestingly enough, you could find these being deposited on Brighton Beach, little less than a week away from each other. And again, just for frame of reference, that's about 4.3 miles between these two geographies. So we talked about the coastal impacts, we've talked about water levels. What information is out there to help, managers, analysis, and things like that. And so I want to touch on physical environmental data that's produced by not only NOAA, but our other federal and state and local partners, the water level data, shoreline data, highlight some of the tools like the lake level viewer, and then again, adaptation strategies as we deal with climate change. So in regards to physical data, one of the first types of data that we work with in understanding the physical setting is getting a good sense on elevation, both the terrestrial and the topo side of things, as well as the bathymetry. And so actually just last year, this is actually a photo from September of 2019, the Army Corps of Engineers JABLTEX, which stands for Joint Airborne Lidar Bathymetry Technical Center of Expertise, was up in our geography actually collecting topobathy lidar. And so this system actually uses two lasers, a near infrared as well as a green laser, to collect information about the topography or the elevation. And so the near infrared helps to provide information on the terrestrial side of things, while the green laser can actually penetrate the water and provide information on the bathymetry. In addition to the LiDAR, they are also flying a high resolution camera capable of collecting imagery at high resolution, less than basically 6-inch spatial resolution. But they also fly a hyperspectral camera as well. And this is really helpful for understanding coastal geology as well as sedimentology, and helping to pull out things around involved with the bottom and the terrestrial along the shorelines. That data can then be used to create digital elevation models. This is up along the North Shore, the Brule River in Cook County, Minnesota. And what's nice about interpolating that LiDAR data and creating these digital elevation models is it allows you to get a 3D representation of the terrain and its associated bathymetry. And so we can start to then pull out elevation values. In this case, we're highlighting areas in red that fall between the record high and record low water levels of Lake Superior. And these are areas then, that are prone to being more dynamic, especially as water levels go up and down through time. And again, this is a digital elevation model that's created from the topobathy LiDAR, as well as other data sets, including Army Corps of Engineers dredge survey data. And we can use this to highlight areas, again, that fall between that record high and record low water levels. And it's really interesting when you look upstream in the St. Louis River here, a lot of those wetland complexes. And if you've watched John's presentation, he's highlighting the epicenter of Bay Delta deposits here as well. And so, these are the areas that are susceptible to any changes in water levels. Previously mentioned some of the imagery on the JABLTEX platform, but I will also point out that there's been a lot of oblique and ortho photos collected along the shorelines in both Minnesota and Wisconsin. And what's really nice about this, especially the multi-temporal aspect of it, is that you can look at these changes over time. And so here's an image on the left from the Minnesota Lake Superior Coastal Program in 2007. of the mouth of the Brule River. And again, a NOAA NGS 2016 image. And you can see how sediment deposition has changed at the mouth of the river. And again, we can see this all up and down each of the shorelines to look for change over time. Where is sediment being deposited? Where is it being eroded? And again, looking at structures along the shoreline, which ones may be susceptible to further coastal erosion over time. The water level data is a very important piece to look at. You know, there's multiple sources to get this, but what I want to point out here are the stations that actually help to feed into things like the NOAA GLERL water level dashboard, as well as the Army Corps of Engineers water level reporting information. And so in Minnesota, we have 2 stations, one in Grand Marais and one in Duluth, Minnesota. These both produce water level information as well as meteorological information. The next furthest or closest one is actually over in Ontonagon, Michigan. And so these are, you know, 2 sites that I typically refer to people when they're looking at water level change along the Minnesota shoreline. And basically, you know, look at which one's closer to you and seeing what water levels are being reported with these different storm events. And so this is just an example from the Grand Marais station, looking from October of 2018 to October of 2019. And we can see that cycle over time. You know, water level is high during the summer, and then again drops down over the winter, and then comes back up. Excuse me, in the summer again. And so, you know, understanding these patterns and that they can fluctuate much more, and they can actually exceed what is reported in the average monthly water levels is another way to inform coastal residents and communities that, you know, you do need to look at this information a little bit more closely, because there is more variability present than what is being reported through those average monthly water levels. One of the things that we're really happy, and it's almost ready for public release, it's actually sitting out there temporarily for people that might be interested in it, is we did develop a hardened shoreline classification data set at a scale of 1 to 2,000 for the entirety of the US shoreline in the Great Lakes region. And this was done in partnership with the Army Corps of Engineers, as well as USGS and other agencies, to help us get a better understanding of the makeup of our shorelines. The one thing you will notice here, though, is we do not include embayments like the St. Louis River Bay, due in part that we're primarily looking at this from the standpoint of direct interaction with waves and water on the lake side. But the information here does provide a really nice synopsis of the shoreline type, both natural and hardened shorelines. And just pointing out here, for example, 192, this is the light pier on Minnesota Point. And so the 192 denotes it as being artificial, 232 denotes it as being a jetty pier, and that 2 that carries through for each of those sets of numbers here is actually the quality of that structure itself. And so this is a way for the Army Corps of Engineers to do an inventory of, you know, what does our coastal infrastructure look like? Where are we noticing areas that are more prone to being potentially impacted or damaged? I'll highlight the lake level viewer. Hopefully a lot of people have had the opportunity to play with it or use it. And so, you know, we do have data available for the Twin Ports area here. But what I really like to show is, you know, we can use this to prepare or look at post-storm impacts. If we take into account the water level during the October 2019 storm event, we can set the water level to 184.3 meters. And again, it was 184.33 meters. The long-term average is 183.41. There was a difference of over 3 feet between the long-term average and the water level that was reported from the co-op station. And we can start to see where there may have been inundation occurring. And in this case, we are definitely seeing some of that inundation that was on the bay side of Minnesota Point being highlighted in this tool. And so one of the things that I've asked about is, you know, if this is the case, we definitely like to hear reports on whether or not the tool was correctly showing this. In 2017, we were able to demonstrate this in Lake Ontario by having field crews from emergency managers go out with GPS and say, yes, this is the edge of the water, provide that information to us, and then again, did the lake level viewer correctly visualize that? And based off of that particular event in Lake Ontario, we were over 90% confident in the tool itself providing the right information. And so that's one of the things that we're definitely trying to work in closer coordination with is the National Weather Service and any of the reports that they might have received, or again, from the community or coastal management programs that we've worked with. We have a lot of data and tools available through the Digital Coast, but we also have a lot of non-data and tools related information. And so this can be found through our topics page. And one of these is actually focused solely on adaptation strategies. And so I just wanted to highlight a few that sit in there. We do have the Adapting to Climate Change, a planning guide for state coastal managers. We do point to living on the coast. Again, that one is solely focused on the Great Lakes. And again, we also work in coordination with SAGE, or the Systematic Approach to Geomorphic Engineering, that discusses a green to gray, in terms of shoreline protection. When is it best to use a green infrastructure or nature-based infrastructure versus a gray infrastructure like a seawall or a bulkhead? And so these are some of the resources we put out there for people to use. And again, connect with other coastal partners. We learn from others, whether they be out on the East Coast, the West Coast, or the Gulf Coast. Similarly, they learn from us here in the Great Lakes region as well. And I also want to just highlight too, we work very, very closely with the Minnesota Lake Superior Coastal Program as well as the Wisconsin Coastal Management Program. Both of these agencies are actively involved with coastal hazards mapping and community outreach and education. And so certainly, we rely on them just like they rely on us. And so it is a team effort when it comes to dealing with these impacts due to climate change and coastal inundation in the Great Lakes. So I'll just leave it with these few takeaway messages. Again, the Great Lakes are some of the most dynamic and directly influenced areas in the U.S. that are impacted by climate change. Again, that interaction between wind, water, waves, and ice makes it very challenging and a very, again, dynamic location to work with. The recent high water levels in coastal storms have definitely led to increased rates of erosion and sediment transport. We can clearly see this when we look at things from Lidar data or satellite imagery or aerial imagery, the amount of change that's occurring over time. The reduced ice cover that was present this last winter in 2019 to 2020, we did see additional coastal erosion occurring because there was no shore fast ice that typically helps to serve as protection along those margins. And so it's definitely had a direct impact there. There are a lot of data and tools available, and certainly I've only touched on a few. There are so many more available through the Digital Coast, as well as our other federal, state, and local partners. And so, definitely here to help people get connected with the right resources as they try to understand these various geomorphic processes, the coastal impacts that they're seeing. And again, it's one thing to see something, but what steps can be done to remediate, to adapt, and become more resilient, providing those resources as well. And so, as previously mentioned, this recording, as well as John's part one of impacts with water levels and change in the coastal area, will be available on Minnesota Sea Grant's webpage under the Twin Ports Climate Conversations page. And with that, I'll stop presenting and see if there's any questions, comments, or thoughts for discussion.
Thank you so much, Brandon. That was great information, and we do have a few questions. I'll remind people to please post your questions for Brandon in the chat box. First question is from Sophia, wondering if you have sources for the data for shrinking beaches and recreational use, damage and loss of private property, loss of coastal, terrestrial, and wetland habitat. Looks like she's working on quantifying loss of community benefits for community impact analysis studies.
It's a really good question, Sophia, and we do not have anything that's holistic across the Great Lakes Basin. I do know that some of the coastal management programs are directly, going out and mapping or putting a GPS point on that. But collectively, there's nothing that exists I know of yet. This would definitely be a very valuable data set right now of the collective impacts that we're seeing with these high water levels. And so typically where we're hearing this is through the various news reporting agencies across the Great Lakes. I've got a running stack. I just copy and paste anytime I see something in a Google Keeps notepad that I keep. But yeah, there's nothing that is available that I'm aware of as a GIS data layer at this time.
Sounds like a great opportunity for some additional research. Thank you. Another question now from Carmelita. Carmelita is wondering how waves and turbidity are impacting drinking water supplies that rely on the Great Lakes for drinking water.
That's a really good question. Obviously we do see the turbidity. And the one thing I will say though is, water intakes are typically much lower. I guess that's the nice thing you could say about it in terms of high water levels is it's actually keeping that turbidity at a much higher part in the water column. In terms of, if it's having a negative impact, I can't say. I'm not a water resources engineer or, utilities manager. But certainly, because of the increased water volume, you'd expect that it's also being dissipated, the turbidity is. Where we're really seeing the turbidity is primarily along the coastal nearshore areas, not necessarily out where the water intake cribs are located at. But again, that might vary though based off of each community and how far offshore they're taking their drawdown for water level or for drinking water.
Thank you. We've also had a couple questions, just so you know, if the presentation will be recorded or the slides made available. And again, those will be posted on the Sea Grant webpage. Brendan, I'm wondering if you could just even back up one slide to show everyone that page. Sea Grant has created a page for us right now. The conversation from last month is there from John Swenson about basically the feeding or not of sand to Park Point, and then this will be made accessible and posted on that site within a few weeks as well. And let's see, another question from Karina, who is glad to hear your voice. She says, we've of course heard that real-time documentation of water levels and impacts is needed right now to better understand the phenomena. Have you been hearing any significant interest in collecting photo documentation this summer? And if so, is there a place for folks to send photo documentation, especially photos with date stamp and geotag location?
So there has been an increased interest in collecting that information. I'm not sure if there's anybody on from the National Weather Service, but that is certainly something too that they are very interested in seeing, especially as a way to validate, their coastal flooding watches and warnings. As far as a central point to where that data can be housed or disseminated, I don't think that there has been anything officially set up yet to do so. But again, a very good idea that does need, again, a way to do this community sharing and learning from one another on the impacts.
Thank you. We do have another question from Connie. Connie's wondering if this is part of a natural 30-year cycle. Does that change anything about how we approach the high water levels and community response?
Yeah, so the 30-year cycle, like I said, it's really tough to see. I mean, I've looked at, is there any correlation with these natural climatic oscillations? Unfortunately, it's just not there, or at least we're not seeing it yet because of the limited period of record in terms of water levels. The one thing that we definitely encourage people to do is, use this as an opportunity to reflect upon what impacts we are seeing, because it is interesting. Last time we saw this in the Great Lakes, especially in Lake Superior, was back in 1985. And I'll admit I was only 4 years old. And so that frame of reference in terms of time period, it's interesting because now after seeing what happened last year, the photos from 1985 are finally coming out of the woodwork. People are like, oh yeah, I remember watering this basement and things like that. I think that, with the advent of the internet and, people sharing information, just like Karina's question about, sharing photos, is creating this record that says, remember when water levels were this high, these are what we were dealing with, and adapting to that and understanding we need to be resilient. So that may mean, yes, putting in shoreline protection in some locations, but also understanding too that if we, alter the systems too much, it can definitely have some impacts, as John presented, last month during his presentation. And so that's where we provide, again, these resources. And I'll just back up a couple more here. Things like the Adapting to Climate Change as a planning guide. This is the opportunity to, get the communities together, discuss the issues they're dealing with, and then find solutions to how best to tackle these. Is it using nature-based infrastructure? Is it using hardened gray infrastructure? But also understanding that with each of those, there are both positive and negative impacts that come with them. And then again, using the community approach, figuring out which ones weigh out best moving forward, I think is the best way of approaching that. But certainly that's the one thing that I mentioned with the water levels. 30 years from now, you'll have a new generation of scientists and a new generation of coastal planners. And the one thing I would say is hopefully history is not lost here. This is an opportunity to document what's happening so that people may learn from it moving forward.
That sounds great. Thank you. And just to reiterate, your key takeaway message is that the Great Lakes coastal areas are very dynamic and have directly influenced by climate change. That's one of your key points, and really helpful for people to know then what is happening with climate change. And we do know that in Minnesota, the top 3 changes we can say are we're getting warmer and wetter, and we're having more damaging rain events, and winters are getting warmer. So kind of overlay that with the lake levels, and then people can kind of take a bigger picture approach. But the data is very helpful, and we are glad to have this. Let's see. Clinton also says it would be nice to be able to demonstrate the land use changes, population density during these cycles, and then use that information in planning.
Yeah, so I didn't even touch on, it's primarily sticking to the coastal ribbon. But certainly, as Clint just mentioned, land use, land covers, that changes due to climate change, from evergreen forest stands to deciduous, timing and type of precipitation over those landscapes can also alter, turbidity loading into the watersheds and the streams that are contributing directly to Lake Superior, as well as, the warming of those waters in those geographies. So yeah, this is another thing that I didn't really touch on, but certainly, the buildup of our coastal infrastructure that's occurred over time as well. You know, the number of people that are moving and living along the shorelines, you know, we're definitely seeing that increase there. And so that's just it. With more people along the shorelines, that's more people that will be impacted as things change over time. So.
It looks like that is it for the questions, and we are slightly past our 1 o'clock closing time. So I just want to remind people, I've posted the link to sign up for climate conversations in the chat box. We've got the third Tuesday in May 19th event coming up next month about transportation and sustainability. And this conversation is being recorded and will be made available within a few weeks on that Twin Ports Climate Conversation page hosted by Minnesota Sea Grant. You can see that link on the screen right now. So let's see. Thank you, everyone. And I've got a note here that says many thank yous to Brandon and fascinating presentation. So thank you very much, Brandon. And thanks everyone for joining us.
Thank you, everybody. Appreciate it.
Have a great afternoon and rest of